Today in Algebra 2, we're going to look at our last section, 7.6, translating the trig functions. So we'll first look at our basic parent functions, y equals the sine of x and y equals the cosine of x. Our transformations, y equals a times the sine of b, parentheses x minus h, plus k, and y equals a times the cosine of b times x minus h, all of that plus k. So we know that a is equal to our amplitude. You know that negative a is an x-axis reflection. We know that b is the number of cycles by the period. A horizontal translation of a periodic function is called a phase shift. If it's minus h, it shifts right h, because again, it's in parentheses, and anything in parentheses comes out opposite. So if it's a plus h, it shifts left h units. Plus k shifts up k units. Minus k shifts down k units. So just like all of our other transformations. Steps to graphing a trig transformation. Identify the amplitude, the x-axis, reflection, period, phase shift, vertical shift. Use the period to label the x-axis. We are actually going to make a table because we've been struggling, I think, the past few days. So I'm going to have us make a parent table. And then we're going to make our transformation table, like what we've been doing on everything else when we were doing transformations of parabolas, cubics, logs, all of those. So we're going to kind of go back to that. Okay. All right, so number one, we're going to look at graph y equals negative 3 sine of x minus pi. Okay, I see that my amplitude is 3, and I have a reflection. So I know that sine usually starts at O and goes O max, but since it's a reflection, it's going to go O min, O max, O. The period hasn't changed, so our period is still 2 pi. Okay? So let's just make a table of the parent function sine of x. Okay? So our basic sine of x, we would have 0, pi over 2, so we would have our quadrantial angles, so 0, pi over 2, pi, 3 pi over 2, and 2 pi. At 0, the sine is 0. At pi over 2, the sine is 1. At pi, the sine is 0. At 3 pi over 2, the sine is negative 1. And at 2 pi, the sine is back to 0. So now we're going to do the negative 3 sine x minus pi. I'm going to make a table for that. It says x minus pi, so it comes out opposite. So we're going to do x plus pi. And then we're going to do negative 3 times our y's. So our y's will be easy. 0 times negative 3 is 0. 1 times negative 3, negative 3. 0, positive 3, and 0. So now we're going to add pi to all of our x's. So 0 plus pi gets us pi. Pi over 2 plus pi. Okay, so this would be like pi over 2 plus 2 pi over 2, which is going to get us 3 pi over 2. Pi plus pi puts us at 2 pi. 3 pi over 2 plus pi is going to put us at 5 pi over 2. 2 pi plus pi is going to put us at 3 pi. So this is what we're going to graph. So starting out here at pi, and I have 3 pi over 2, 2 pi, 5 pi over 2, and 3 pi. I need up to positive 3, down to negative 3. I graph this at pi, I'm at 0. 3 pi over 2, I'm at negative 3. 2 pi is 0. 5 pi over 2, positive 3. 3 pi. There's our graph. Okay. So that was one of the easier ones. Okay. If I needed to extend my x-axis, I could. Okay. So I wanted to. So 5 pi over 2. So then this would be 7 pi over 2. And I know I'd be back down here. Then we would go to 4 pi, 9 pi over 2, 5 pi. We would just keep going. Let's look at number 2. Y equals 1/2 cotangent of x minus pi. Again, I see that the period hasn't changed, so I know that my period is still pi. So we don't have to worry about that. I see that it's going to go right pi. Okay, so it's going to go right pi units. Again, let's make a table of our cotangent, our basic parent, the cotangent of x. Remember that the cotangent had asymptotes at 0, so we started with an asymptote at 0. Then we went to pi over 4. Then we went to pi over 2, 3 pi over 4, and then to pi for our next asymptote. The cotangent at 0 is undefined. The cotangent at pi over 4 is 1. The cotangent at pi over 2 is 0. 3 pi over 4 is -1, pi undefined. So now we're going to do the 1/2 cotangent of x minus pi. I'm going to do an xy table for that. Again, I'm going to have x plus pi, and then I'm going to have 1/2 y. If I do my y's first, undefined times a half is still undefined. So my undefineds are all still undefined. 1 times a half, 1/2. 0, -1/2, and then I'm still undefined here. 0 plus pi puts me at pi. Pi over 4 plus pi puts me at 5 pi over 4. Pi over 2 plus pi puts me at 3 pi over 2. 3 pi over 4 plus pi puts us at 7 pi over 4. Pi plus pi puts us at 2 pi. All right, so now this is what we're going to graph. So again, I'm starting at pi, and I'm ending at 2 pi. So then halfway between is my 3 pi over 2. This is my 5 pi over 4. This is my 7 pi over 4. Up 1, down -1. Again, if I wanted to continue my graph, right, I would just continue on. So 1, 2, 3, 4, 1, 2, 3, 4, 5. So then I know that my next asymptote would be at 3 pi. So this is going to be 3 pi. So then halfway between 2 pi and 3 pi is 5 pi over 2. This would be 9 pi over 4 and 11 pi over 4. So then if I wanted to graph this, so at pi, undefined. 2 pi, undefined. 3 pi, undefined. I know that 4 pi would be my next undefined. 5 pi over 4, I'm up at 1/2. 3 pi over 2 is 0. 7 pi over 4, -1/2. So this is my graph. Again, it would follow the same pattern this way if I needed 2 full cycles. Okay. Let's look at number 3. Y equals the cosine of x minus pi minus 3. Again, I see my period hasn't changed. So let's just do the cosine of x. Let's make a table for the cosine of x. I know that my cosine, if I was graphing my regular cosine, I would have 0, pi over 2, pi, 3 pi over 2, and 2 pi are quadrantals. At 0, my cosine is 1, pi over 2 is 0, pi, -1, 3 pi over 2 is 0, 2 pi, we're back up to 1. So now if we do cosine of x minus pi minus 3, my table, I'm going to have x plus pi, y minus 3. So if I add pi, 0 plus pi gets me pi. Pi over 2 plus pi puts me at 3 pi over 2. Pi plus pi puts me at 2 pi. 3 pi over 2 plus pi, 5 pi over 2. 2 pi plus pi, 3 pi. Subtract 3, so 1 minus 3 puts me at negative 2. 0 minus 3, negative 3. Negative 1 minus 3, negative 4. Negative 3, negative 2. This is what we're graphing. So again, here pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi. If I needed to keep going, so this would be 7 pi over 2, 8 pi over 2, which reduces to 4 pi, 9 pi over 2, and 5 pi. Need down, so negative 2, 3, negative 4. So I'm going to graph this. Pi, I'm at negative 2, 3 pi over 2, negative 3, 2 pi, negative 4. Back up, back up. That gives me 2 full cycles of this one. Remember that these continue on. So this is max O, min O, max O, min O. Right, let's look at number 4. So on this one, we see that we actually are going to change our period. So the period is going to be 2 pi divided by our b is 2, period of pi. Right. If it's easier, we can start with the parent function, the cosine of 2x. So if I had a cosine of 2x, I'd start at 0, but I would end at pi. So then I'm looking at 0, pi over 4, pi over 2, 3 pi over 4, pi. I could keep going if I wanted. 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. I know this is going to be my max, my O, my min, my O, my max, my O, my min, my O, back to my max. So then the secant, so our parent function, what we're trying to graph, the secant of 2x. My x's are going to stay the same. 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. My y's, okay, so now remember that we're going to flip all of these, okay? So 1 over 1, still 1. 1 over 0, undefined, so this is an asymptote. Negative 1, undefined. 1, undefined. Negative 1, undefined, and 1. So now we're going to do the transformations. So now if I do the secant of 2 parentheses x plus pi, all of that plus 3, make an xy table for that. So x minus pi, y plus 3. 0 minus pi, negative pi is where I'm starting at. Pi over 4 minus pi puts me at negative 3 pi over 4. Pi over 2 minus pi puts me at negative pi over 2. 3 pi over 4 minus pi puts me at negative pi over 4. Pi minus pi puts me at 0. 5 pi over 4 minus pi puts me at pi over 4. I wanted to keep going. 7 pi over 4 minus pi puts me at 3 pi over 4. 2 pi minus pi puts me at pi. 1 plus 3 puts me up here at 4. Undefineds are still going to be undefined. Negative 1 plus 3 puts me at 2. This is still undefined. 1 plus 3 puts me at 4. Undefined. Negative 1 plus 3 puts me at 2. I think I got off a little bit. 1, 2, 3, 4, 5, 6, 7. So this, I made a mistake on this one, writing this one out, I think. So let's see. So 3 pi over 2 minus pi puts me at pi over 2. 7 pi over 4 minus pi, so that's 3 pi over 4. 2 pi minus pi puts us at pi. There we go. So then this is an undefined. 1 plus 3 puts us at 4. Okay, so I'm going to graph these. Actually, let me move that over a little bit. I'm going to get the whole thing in. So if I'm at negative pi over 2, this is negative 3 pi over 4, negative pi over 4, pi over 4, pi over 2, 3 pi over 4, and pi. I'm going to go ahead and put in my asymptotes. So I know at negative 3 pi over 4, I have an asymptote. At negative pi over 4, I have an asymptote. At pi over 4, I have an asymptote. 3 pi over 4 asymptote. So then at negative pi, I'm up at positive 4. I need to go back and 1, 2, 3, 4. So negative pi, I'm up at positive 4. Negative pi over 2, I'm up to positive 2. 0, I'm up to positive 4. Pi over 2, I'm at positive 2. Pi back up to positive 4. Remember, we're graphing parabolas here, okay? So this is going to be a parabola opening up, parabola opening down, parabola opening up, parabola opening down, parabola opening up. All right, so that's number 4. So now we want to go to the next page. We look at number 5. Cosecant 2x minus 3 pi, all of that plus 1. Again, we're going to have a different period. So the period, 2 pi over 2 equals pi. So again, I know that the cosecant of its parent function is really the cosine, the sine of 2x. So the sine, I know, usually starts at 0. I'll move all of this down here. So the sine of 2x. I know that my sine usually starts at 0. I know I have 5, right, points. I'm ending now at pi. So halfway between 0 and pi, I know I'm at pi over 2. Halfway between 0 and pi over 2, I know I'm at pi over 4. And then this is 3 pi over 4. So the sine at 0 is still 0. The sine at pi over 4, 2 times pi over 4 is 1. The sine at 2 times pi over 2 is 0. The sine at 2 times 3 pi over 4 is negative 1. The sine at 2 pi is 0. So then the cosecant of 2x, using the same x's, 0, pi over 4, pi over 2, 3 pi over 4, and pi. So now I'm just flipping all of these. So 1 over 0, undefined. This is a asymptote. 1 over 1 is 1. 1 over 0, undefined again. -1, undefined. So now we're going to do the transformations. So I'm going to have x plus 3 pi opposite y plus 1. So 0 plus 3 pi puts me at 3 pi here. Pi over 4 plus 3 pi. Okay, so if I do a common denominator, so that's 12 pi over 4 plus pi over 4, 13 pi over 4. Pi over 2 plus 3 pi puts us at 7 pi over 2. 3 pi over 4 plus 3 pi puts us at 15 pi over 4. And pi plus 3 pi puts us at 4 pi. Add 1. All of my undefined stay undefined. 1 plus 1 is 2, undefined. -1 plus 1 is 0, and undefined. So this is what we're graphing. So this time I'm starting out here at 3 pi. I'm stopping at 4 pi. So between 7 pi over 2. This is my 13 pi over 4. This is my 15 pi over 4. I know that these are asymptotes. You need up to 2. So 13 pi over 4, I'm at 2. 15 pi over 4, I'm at 0. This is my parabola opening up. This is my parabola opening down. Let's look at number 6. A tangent. I see that I don't have a b, so my period is still pi. So if I look at my tangent function, if I make an xy table of my basic tangent, I know tangent, we start at -pi over 2 with an asymptote. Then we go to -pi over 4, 0, pi over 4, and pi over 2. This is undefined. This is -1, 0, 1, and undefined. So now we're going to do x plus pi over 2 and 3y, since we have an a of 3. So -pi over 2 plus pi over 2 puts me at 0. -pi over 4 plus pi over 2 puts me at pi over 4. 0 plus pi over 2 puts me at pi over 2. Pi over 4 plus pi over 2 puts me at 3 pi over 4. Pi over 2 plus pi over 2 puts me at pi. And defines are still undefined. -1 times 3 puts me at -3, 0, and 3. So there's 3, -3. So this is pi over 4, pi over 2, 3 pi over 4, and pi. These are my asymptotes. Pi over 4, I'm at -3. Pi over 2, I'm at 0. 3 pi over 4, I'm at 3. So this is my graph. All right, one more. So number 7, y equals cosine 3x plus 3 pi over 4. We see that we have a period change. So my period is 2 pi over 3. So the parent function cosine 3x. I know cosine starts at 0. This time I'm stopping at 2 pi over 3. Halfway between 0 and 2 pi over 3 is pi over 3. Halfway between 0 and pi over 3 is pi over 6. So then this is going to give me pi over 2. The cosine at 3 times 0 is 1. Cosine at 3 pi over 6 is 0. 3 pi over 3 is -1. 3 pi over 2 is 0. 6 pi or 2 pi is 1. Our transformations. We're going to do x minus 3 pi over 4. and then our y's stay the same. So 1, 0, -1, 0, and 1. 0 minus 3 pi over 4, -3 pi over 4. Pi over 6 minus 3 pi over 4 puts me at -7 pi over 12. We're just getting common denominators to subtract these. Pi over 3 minus 3 pi over 4 puts me at -5 pi over 12. Negative pi over 4 and negative pi over 12. Okay, so this is what we want to graph. So negative pi over 12. Negative pi over 4. Negative 5 pi over 12. Negative 7 pi over 12. Negative 3 pi over 4. I just need my 1 and my -1. So negative 3 pi over 4, I'm at 1, 0, -1, 0, and 1. So that is our graph. Okay, so I'm hoping that by making the XY tables of the parent function, that helps us find the labels for the x-axis for once we've found the period, and then make the new XY table with the transformations like what we've been doing. So that wraps up 7.6. Your homework will be exactly like this. And then we will have test review and our chapter test.